Okay, here's a video to help with the homework 414, that first problem where we're using that tangent button to get our slope ratio. What I'm doing is I took a problem from 412 to kind of introduce those first two problems and show how this is all connected. So when we started chapter 4, what we were doing was looking at these slope triangles with a slope angle, and these slope angles told us a slope ratio. Right? We knew 11 degrees, we knew 18 degrees, 22 degrees, and 45 degrees. That was the first ones we learned. And we said, okay, well, 11 degrees tells me it has a 1:5 ratio, and I set that equal to the rise over the run of the triangle they're giving me, which is this triangle right here. And so the rise is y, because it's across from the 11. The run is 20 then, and I can cross multiply and solve. 1 times 20 gives me 20. 5 times y gives me 5y, and I could say that, well, y must equal 4. Okay? Now, the big thing there is, okay, the 11 degrees told me my slope ratio, and then I can set up the rest of the problem. We learned in lesson 414 that there's a lot of angles that we do not have a slope ratio for, that we do not have an easy, nice, memorized slope ratio for, or one that's not on our trig table. And that's what these problems are here. If we have a degree like 8 degrees, we don't know what ratio goes with that. So what we can do is we can use the tangent button on our calculator to figure out that slope ratio. Okay? So if I bring up my calculator, what I can do is I can click my tangent button, and I can say the tangent of 8 degrees, because that's the angle that I'm working with, is going to give me 0.14. Okay? And so my slope ratio, like I did here with 1/5, my slope ratio is going to be 0.14 over 1. So 0.14 over 1, that's my slope ratio for 8 now. That equals the rise over the run. Since t is across from the 8, it's across from it. T is the rise, 82 is the run. 1 times t gives you t, and 0.14 times 82 gives me 11.48 as a length for t. And this is really how we get into trigonometry here. So we started with those ones that we know that were nice, like 11 with the 1/5, and now we have to get into how we can use tangent to figure out our slope ratio there. So we'll set up the next one, and then hopefully we can go from there. Okay, this time we have a 75-degree angle. 75, I don't know what the slope ratio is off the top of my head, so what I can do again is use the tangent of 75. Tan of 75. Oops. Tan of 75 gives me 3.73. So I can say, okay, 3.73 over 1 is my slope ratio for 75. Set it equal to the rise over the run. Since 12 is across from the 75, that's my rise. So I got 12 over p. 1 times 12 is 12. P times 3.73 is this, 3.73p. Divide both sides by 3.73. So 12 divided by 3.73 gives me 3.22 as my side length there for p. Okay? I'll leave the last one for you so that you can practice this a little bit more, but really the key difference is we've seen problems like this in chapter 4. Oops, wrong one now. We started with easy ones with good slope ratios like 1/5 that went with the 11, and now we're working with more difficult ones like 8 degrees and 75 degrees where we need to use that tangent to come up with the slope ratio.